Okay, so today we are going to be looking at the last part of Module 3. We did a lot of work yesterday. We are going to continue today. So the last part is kinetic energy and potential energy. It's a very simple aspect. It's just a bit technical. So with kinetic energy and potential energy, we understand that kinetic energy is the energy that is associated with the state of motion of an object. And we understand the fact that the faster an object moves, the greater its kinetic energy. And it's still the normal formula, which is half mv squared. The same formula that you knew, m being the mass and the v being the velocity. So this simply means that there are two factors that influence kinetic energy of an object. It is the mass and the velocity. Okay, the magnitude of the kinetic energy is dependent on the mass of the object. So the greater the mass, the greater the kinetic energy. And then another one is the velocity. So the larger the velocity, the larger the kinetic energy. So this is just a brief introduction. And then with the potential energy, there is the energy which depends on the position of an object, and it's an energy that an object possessed at a state of rest. That is potential energy. Okay, so for potential energy is mgh, m being the mass, and then we have g, which is the gravity, and then the h, which represent the height. So the potential energy of a body is the energy which depends on the position of an object in a gravitational field. So when a mass, a body of a mass in kilogram is raised vertically a distance h meters, the work done against gravity will be mgh. So of course we know all these things, and then the unit of potential energy and kinetic energy is in joules. This is where I'm going. This is actually where our calculations are going to be pointing to the law of conservation of energy. You might be asked to state this law in the exam. So it is generally known that the energy cannot be destroyed or created, but it can be transformed from one point to another, from kinetic to potential, or from potential to what? To kinetic energy. And in certain situations, you can see here, potential energy can be changed to kinetic energy and vice versa. So with the law of conservation of energy, if there is a loss in potential energy, there is a gain in kinetic energy. And if there is a loss in kinetic energy, there is a gain in potential energy. So we're going to be looking at this. Sometimes you might have a formula where you are being asked to determine a potential energy, and then you have to write it as gain in potential energy. So with a gain in potential energy, of course, there won't be gain in kinetic energy. There will be loss in kinetic energy. And sometimes you might have gain in kinetic energy and loss in potential energy, and then you will now have your formula to be half m what? Mv squared. So this law of conservation of energy principle is what we are going to be basically looking at here in terms of application. So kinetic energy, potential energy, and the law of conservation of energy is combining both. So let's look at some questions here, and let's see how this question, I took it from my old textbook, so I'm not sure. I think the data should be the same. Question 1. There is a question here. The mark is not shown. The question says that a body with a mass of 25 kilograms is at rest 20 meters above the ground. Let's say this is the ground, and then let's say it is at rest at this point here, 20 meters above the what? Above the ground. It's allowed to fall freely. Now, the first question says that you must calculate the potential energy when it is 15 meters above the ground. So let's say this is 15 meters. It was at rest. It will still have a little bit of potential energy uh, at exactly 15 meters above the ground. So how do you calculate the potential energy there? You just use the normal formula, which is what? M times G times height. So the potential energy when it is 15 meters above the ground, the mass is what? 25, G is 9.81, and then the height is what? The height where you are going to use 15. Potential energy will be what? 0.75. What's the unit? Joules. So you can write this in kilojoules, 1, 2, 3. You can write this as 3.7 what? Kilojoules. Let's look at the second question. So I'm going to change the slide. I'm going to read from here. Can you just copy it down? Kinetic energy, just kinetic energy when it is 15 meters above the ground, the B part, and then the C part, write down one too. Because I'm going to change it. I'm going to be reading it from my textbook here. The B part. How will you determine the kinetic energy when it is 15 meters above the ground? Kinetic energy when it is 15 meters above the ground. So, because you are being asked to determine the kinetic energy, so gain in kinetic energy is going to be what? Going to be equals to loss in potential energy. So, this is where you use the law of conservation of energy. Gain in kinetic energy is going to be equals to loss in potential energy is going to be equals to mgh. But now you are going to subtract h. Let me name down one h1. It's going to be 20 minus 15. So you are going to subtract those height. Loss in potential energy is going to be equals to the mass. The mass is 25, 9.81. And then we're going to have, that's going to be 20 minus, you see when it is 15 meters above, so it's going to be 20 minus 15. You're going to subtract the height. It simply means that, who is that? From outside. This is 5 meters. Kinetic energy at this point. So you subtract 20 plus 15. So this will give you what? Kinetic energy is one what? 122.25 joules. Let's look at the third one there. Kinetic energy just before it hits the ground. So in that case, if you are being asked a kind of question, it's still the gain in kinetic energy is going to be equals to loss in potential energy is going to be equals to mgh just before it hits the ground. So you're going to use the mass 25, 9.81. You are going to use the total height now, 4,900. Point what? It's just 4,900, right? 4,900 joules. Let's look at question 2 because of time. Let's look at this one. Data. We were told that a mass of 8 kilograms falls freely from rest and reach a velocity. Here we are given velocity, 15 what? Meters per second, just before it hits the ground. The first question says that we must calculate the initial potential energy because, of course, it was initially at rest because they said from rest. So, if you are being asked to calculate the initial potential energy, you are going to write it as gain in potential energy equals to loss in kinetic energy, which is going to be equals to half what? Half mv squared. So this is 1 over 2 multiplied by 8 multiplied by what? 15 squared. 900 joules. The last question there, the height through which it falls. So we understand that gain in potential energy is equals to loss in kinetic energy equals to m times g times h. So we can substitute that 900 there to be equals to what? M times g times h. So we can calculate the height. They say the height through which it falls is going to be 900 divided by what? The mass, which is 8 times gravity, which is 9.81. What will be the height? 11.47 meters. So that's the height through which the object of mass 8 kg falls from rest with that particular velocity. Let's look at a more tricky one. Questions. This question 2. Let's look at question 3. Let's look at question 3 together. We were given a mass of a car. It said a car with a mass of 800 kilogram accelerates uniformly from rest up an incline. Mass 800 what? Kilogram. The incline is 1:40. So it simply means that uh, for horizontal movement of 40, it would have gone 1 meter high. And then it said it reaches a speed of 80. Let me just convert this straight because this normally gives me issue. 80 times 1000 divided by 3600 is what? 22.22. So this is 22.22 meters per second after 1 minute. So 1 minute, the time is 1 minute, which is the same thing as what? 60 seconds. The first question there says that we must determine the acceleration of the car. So with that one is easy. You can use the equation of motion v equals u plus what? Plus at. And then because the initial velocity is 0, v is equals to at, which is going to be the acceleration multiplied by what? Multiplied by what? 60. So v is 22.22 meters per second. Acceleration multiplied by 60. We divide both sides by 60. It's going to be 22.22 divided by 60. 37 meters per second squared. Okay, so what will be the potential energy after 60 seconds? That's the potential energy after 1 minute. Now we know that potential energy is equals to what? mgh. I'm going to solve that on another page. When I'm done, then I'll go back. Potential energy formula is mass times gravity times height. So we are to determine the potential energy after 1 minute. So the time there is what? 60 seconds. So we have the mass. The mass is what? The mass given to us is 800. 9.81 times height. This is what we don't. This is what we don't have, which is the height. You can get the height. They said it's from rest up an incline. So the direction of motion will be up there. So we can say that we can use sine here. Sine theta is equals to height divided by distance, so that we can get the height will be equals to that distance, which is s sine what? Sine theta. So we need to get that distance there, that s. So with that distance there, we can use any of the equation of motion. We can use s equals to ut plus half at squared. Initial velocity is 0. We can get our distance. We can use this formula at squared. So distance will be equals to 1 over 2. Acceleration that we calculated there is 0.37. The time is what? 60 seconds. Can someone give me the value of the distance? If you can get the distance there, you can get the height, then we can substitute to get the potential energy. You understand what I'm doing there? 666 what? Meters. So let's get our height from equation 2. It's going to be 666. Now we can represent that sine theta with 1 over 40, because that is 1:40. So just divide that 666 by 40, 16.65 meters. Now we have the height. Then we can now use this formula to calculate the potential energy. So I'm just going to write everything here because of space. That's going to be the mass, 800 times what? 9.81 multiplied by the height, which is 16.65. What will be that? The reason why I'm solving it is for you guys to see um, how you approach the question. I'm still going to give you work to do. Can you guys try question 4? Here we are given the mass. Let's see what's going on here. The mass of the hammer is 2 kilograms. Falls freely from rest to a height of 1.6 meters. And it drives a nail into a wooden block. Calculate the velocity of the hammer just before it hits the nails. So here is going to be gain in kinetic energy because we need velocity. Gain in kinetic energy is going to be equals to loss in potential energy. Half mv squared, or you can write 0.5 times m times what? Times v squared. Loss in kinetic energy, we can calculate loss in kinetic energy. mgh, our mass is 2 kg multiplied by 9.81. It falls a height of what? 1.6. Can someone give me the value of the loss in potential energy here? 31.39 joules. So referring to this here, we can determine the velocity. 31.39 equals to 0.5 times m times what? Times v squared. So you can calculate your velocity here, make v the subject of the formula. 31.39 divided by 0.5 times mass, which is 2. Here we can determine our velocity, 5.6 meters per second. The resistance of the wood, if the nail is driven 20 millimeters into the block, any idea? Work cannot be done if there is no energy. So we got 31.39 joules. So we can say that 31.39 equals to that resistance force times. They said it moves in a distance of 20 what? So 2 meters is going to be what? 0.020. The resistance force will be equals to 31.39 divided by 0.020. We can associate energy to work done. Or we can say kinetic energy, because there is a movement there. We can associate gain in kinetic energy to work done, which is the same thing as what we calculated here, because we already established here that gain in kinetic energy is equal to loss in potential energy. Then we calculated the loss in potential energy here to be 31.39 joules. This will give us 1569.5 newtons. Equation 5, 3.3.